Alright, so I hope this is recording. I think I'm plugged in everywhere. Let's take a look at these rational functions, and this time we're including the intercepts and a little bit more, as it says. So, to define the y-intercept, I let x equal 0. So we often say we plug 0 into the function. In the numerator, we just get negative 45. In the denominator, we get 22. Change this 11x to 13x. All right, sorry about that. Does this reduce 3, 9, and 5? 3, yeah, this one doesn't reduce. Okay, so yeah, that's my y-intercept. Now, they want me to find the x-intercepts, and that's why I have you change that. Let's let y equal 0, the output of the function. So a fraction the numerator determines if this fraction reduces to 0, but you have to be aware of the denominator because it can't be a 0. You don't want to call a whole as an x-intercept. So if we have x squared plus 13x, otherwise we'll have to use the quadratic formula. We can do it, but it'll just the integer values will come out nicer. Alright, so if I factor my numerator, I've got x plus 9 times x minus 5. I've got x plus 2 times x plus 11. Alright, so I don't, nothing cancels. So if this does reduce to 0, it's because of the numerator. And I am not concerned about negative 9 causing division by 0, nor am I concerned about positive 5. So these are my x-intercepts. Alright. Now it also wanted, what else did it want? The end behavior, and then, so the end behavior, we compare the degree of the numerator against the degree of the denominator. I have a degree of 2 in the numerator, a degree of 2 in the denominator. So the end behavior is a horizontal asymptote. Always give an equation. It's the line y equals, well, when the degrees are equal, it's a ratio of the leading coefficients, and 1 divided by 1 is 1. Now, as I mentioned it to both classes today, and some people did have a preference to see this as x is approaching negative infinity, the y values are getting closer and closer to 1. That's what that horizontal asymptote is telling us. Remember, your graph, an asymptote, I always think of it kind of like a magnet, and it's just pulling that curve closer and closer and closer to it, whether it's horizontal or vertical. Now the difference, horizontal asymptotes close to the origin, your graph might actually cross it a few times close to the origin, but out very far away, the end behavior, it'll never cross it when you're far away from the origin. And a vertical asymptote, the graph will never ever cross it because that value is not in the domain. So as x approaches positive infinity, we have that y is also going to 1. So you could write this as an answer, or you could write this as an answer. I would accept either one of those. Just two different ways of expressing the same idea. Alright. So what next? Vertical asymptote and whole. So let's factor the numerator and denominator. Remember I said change this to 13. Sorry about that. X plus 9 x minus 5, x plus 2, x plus 11. So as far as the vertical asymptotes go, there's no common factors, so we're throwing negative 2 and negative 11 out of the domain, and they're both vertical asymptotes. So we have this graph is going to have two vertical asymptotes. They are the lines x equals negative 2 and x equals negative 11. Then it wanted us to identify if there was any holes in the graph. Yeah. Well, there were no common factors, nothing canceled, so there are no holes in this graph. Alright, so I hope that helps. Talk to you later.